Okay, let's get started. So, hello and welcome to another episode of DriveOhio Toolkit Tuesday. This is a free webinar series that we like to call Bite-Sized Learning for Busy Educators. I've got some great friends with me here today, Ryan and Cy, who are going to talk about some outstanding STEM curriculum that they've developed. We'll walk you through all that as we get rolling here today. So, to start off, just a few reminders. This webinar is being recorded, and if you're in the audience, audio will be disabled, but you can absolutely participate through the chat. We encourage questions throughout today's discussion, so please submit any questions as you think of them, and we'll be sure to get to as many of those as we can. And all of these slides and the recording will be shared afterwards through our website and through our YouTube channel, and we'll highlight that later in the episode. And all of our discussion today is in support of use of the DriveOhio Educator Toolkit. It's a free online collection of resources to support K-12 education all across Ohio, exploring next generation transportation careers, a few of which we'll be talking about today. So with that introduction, let's get our speakers introduced. I'm going to start with Ryan, and I'll ask you both the same question. By way of introduction, give us a little bit about your background and tell us, what does a typical day look like at University of Cincinnati? Ryan, take it away.
Great. Rich, thank you for that introduction. Thank you so much for taking time out of your schedule to join us for this webinar. My name is Ryan Mahle. I'm a research engineer at the University of Cincinnati. I work specifically for the Center for Smart, Sustainable, and Resilient Infrastructure. My background professionally is as a geotechnical engineer. So think slope stability, landslides, retaining wall design, foundation design, and things of that nature. Right now, I'm really focused and passionate about the application of new technologies, specifically sensor technologies on infrastructure, right, as a civil engineer, but also transportation and how they fit together. So what does a typical day at UC look like? Being part of a research team, I get the opportunity to work on a diverse degree of projects. So either being the lead investigator on a principal project or serving as support on a project. Obviously, we're at the University of Cincinnati, so there's an academic piece of that as well. So some days are as simple as grading papers, but there's always this there's this atmosphere of creativity, there's this atmosphere of innovation, and when given the opportunity, I like to, because I'm so passionate about it, spend that time collaborating with educators. I know many are on this call, and not only the information about engineering education, but the inspiration piece as well.
Outstanding. Thank you. And Cy, similar question, but maybe a different tense, right? Because you're as a newly minted PhD. Congratulations on that. Maybe you can tell us what it was like at UC, and also maybe talk a little bit about what you're up to these days as well.
Yep. Thanks, Ryan. And thanks, Rich. Thank you so much for this opportunity to be here. Yeah, I'm happily graduated with a PhD last summer. Worked with a great team at University of Cincinnati Infrastructure Institute. We focused completely on technology, smart mobility purely during my PhD. Just from my background, I'm an electrical engineer, so my PhD was in electrical engineering. And the focus has been on using technology to improve everybody's experience in streets pretty much. So that's what we are focused on. Thanks in large part to Ohio DOT's Student Transportation Advancement Research program, through which we developed a good technology. I think that kind of helps people safety, road user safety, which has been focus of my PhD, and as well as what we are going to discuss today. In part is developing workforce who think about this technology to be used as road user safety mechanisms.
Outstanding. Thank you. And you can each jump in on this one if you like, but Ryan, since it's right behind you in the picture there, you want to tell us a little bit, what's this Digital Futures? What's that all about?
Fantastic. Yeah, I am at Digital Futures right now. We're pleased to have offices in the advanced transportation wing of Digital Futures. Really, Digital Futures is a I would say a collaborative, cooperative learning space. It's also a space where a lot of research takes place, and a lot of integration of that same research takes place as well. This physical structure really is, I believe, a testament to the University of Cincinnati's investment to research, innovation, future technologies, and certainly that includes our future workforce as well.
Yeah, I think what I would add is, I think, through my PhD, I worked with a couple of teams at Digital Futures. I think Tri-State Trails is one, a nonprofit focusing on bike trails expansion in greater Cincinnati area, but also, Future Mobility Design Group, who's focusing on envisioning how future mobility should look like. I think phenomenal exposure to thinking future and how could real world problems be solved with existing technology.
Yeah, and just piggybacking upon that, just kind of underlining, Cy, I think you made a great point. Real world problems, a lot of times maybe the thought, misconception, perception, or reality is that sometimes that academic research or that academic state of art doesn't always get to impact state of practice or make too much of an impact, right? That thesis dissertation just sits on a bookshelf somewhere. This is by no means the type of research that is being done here at Digital Futures. The focus is always for every team to make an impact, to invest in somebody's lives, and really to make it as personal as possible. I really feel like there's a human element that is part of the culture of this space.
That's outstanding. I appreciate that. Yeah, I'm always impressed and energized when I visit down there. The innovation district that surrounds it is super impressive. You got the 1819 Innovation Hub nearby, and for anyone who hasn't been down there to see that ecosystem up close, definitely worth a visit and several visits, I would say. So, Ryan, you get the next question. What the heck is Eng to you? And how did you spend your summer in 2023?
Man, there's so much to say here. This might be a webinar of its own, but Eng2U is really our brand for all the educational resources that the Center for Smart, Sustainable, and Resilient Infrastructure publishes or produces. So the Center for Smart, Sustainable, and Resilient Infrastructure, where I work, there's a digital infrastructure piece that we recognize. There's a material infrastructure piece, everything from the asphalt to the concrete and so on and so forth. But there's also a human infrastructure piece. We recognize that we, as educators, but also as engineers, need to make a significant investment in tomorrow's transportation and engineering leaders. And Eng2U is just that. It's taken from this notion of V2V technologies, or vehicle to vehicle, or V2X, vehicle to everything, or V2I, vehicle to infrastructure, and so on and so forth. Eng2U is this notion that we really want to make a connection. We want to take this, unfortunately, sometimes too abstract notion of what engineering is or what it could be, and make, again, an impact in the lives of middle school and high school students, as well as the educators that inform them. And so really that's what Eng2U is all about in a kind of a big picture type of view. But in the summer of 2023, we were able to partner with DriveOhio and the Ohio Department of Transportation to work on a project for which the keystone was really an engineering camp held here at Digital Futures, for which, man, we had almost 150 applicants. About 40 to 50 of those were selected for a 4-day free camp in which we walked them through the engineering design process of connect, learn, explore, and lead. And so it was the focus of this camp was on, again, the application of new sensor technologies to transportation, And many of our sessions were everything had to do with hands-on learning. And so over the course of those 4 days, they were able to build, design, process the associated data, clean that data, train a model, and then test and drive their own autonomous vehicles. I have an example of one right here. So essentially what we did is we took remote controlled cars, RC cars, we repurposed them with a Raspberry Pi computer. We outfitted them with a camera, machine vision sensor, and we're able to use this as a relatively inexpensive learning tool for the students over the course of those 4 days. All of this reaching a fever pitch in a final race in which the autonomous cars had to race. It was actually so close between two design teams. We had to go back to the footage to determine who had won the competition. So again, the emphasis here was collaboration and being part of a team, but keeping everything as hands-on as possible to give them access to a world of engineering that they probably never would have ever even heard about, which is very, very exciting. So we're really grateful for the opportunity to have done that. And because of this camp still exists in perpetuity. So even now, we're accepting applications for the 2025 edition of this camp, July, I believe it's 7th through the 11th here at the Engineering College at Digital Features. If you or your students are interested, you can find more details on the College of Engineering and Applied Science page associated with the University of Cincinnati.
That's great. And I mean, I love that it was hard to narrow down the pictures. You had so much footage from everything you all did. And the same will be true when we get to size example too. But when, here's your, I guess this is your final competition, right? Is that what I'm looking at with that big test track there?
Correct. And so in the main room, I would say maybe about 60%, if not 70 or 75% of that room was kind of rededicated as a test track where we were able to train and test our models, collect data using our own autonomous vehicles that we were building. And maybe the data from those 4 days really speaks to itself. I think none more significant than we had, I think, nearly 70% of the students either saying that they previously were not interested in a career in engineering, moving the dial to now being open, if not excited about a future career possibility in either transportation, engineering, or engineering in general.
That's great. That's outstanding. Yeah, and you had a whole variety of speakers too, right? You had some early careers, some industry folks coming in. Is that right?
We sure did. We had Leidos, we had civil engineers, we had Air Force engineers. We would really use the morning sessions to set them up for the afternoon sessions, which we were entirely hands-on. Not only that, given that the camp was here at Digital Features, able to collaborate with many of the research labs that are right here, either down the hall or on another floor. So they got, in the morning, a lot of exposure to artificial intelligence and augmented reality and virtual reality and all of these in drones and all of the cool innovation that's taking place here on a daily basis. And we were able to kind of give them enough resources and education in the morning, although it was very fun and energetic, but you might call that a little bit more of the quote unquote passive learning to set them up for the hands-on, active, participatory experience in the afternoon. All of the curriculum resources, all of the sessions really formed the basis for the curriculum content, the lesson plans, and the other resources that are actually now available on the DriveOhio educator Toolkit site. So you can do, educators who are listening to this webinar, do many of the same things that we did in those afternoon sessions, having been provided the free resources that you have access to through the Toolkit.
That's great. Yeah, and we'll take an even deeper dive into that in a few minutes, but I think that's a perfect overview from what you did that summer. So thank you for all that. Sai, similar question. What is cave light? Enlighten us on that. And how did you spend your summer that same year of 2023?
Yep. Thanks, Rich, and great job, Ryan. I think some of the things that we've done throughout 2023, I think produced some gems. Hopefully, we'll start seeing them as directors and in state and federal level administration at some point, because I've seen that sort of passion students brought to the summer camps. What you see, I think, at the front of this is the little cave light that we built with support from Federal Highway Administration, Saxton Lab, which is partly Lida's group as well. Students were hands-on engaged through College of Engineering summer camp. So we got a slot in a 4-day week. I think that's what the College of Engineering has planned and recruited students for. So with about at least 100 students, we had rotations. So each student or a group of students got to spend 20 to 30 minutes on the kit. So part of the group, as you see here, one group is working on the traffic light side of it, just to understand how real traffic signal operations kind of work in real world. Based on that programming, we established a wireless communication to the vehicle, where the other group of students are now working on the vehicle side of things to understand how does this red, green, yellow translate into vehicle motion, autonomous vehicle motion. So right now, let's say it's connected, it's getting all these messages. How does the vehicle unpack them and take a decision to stop, slow down, or even go? So students got to experience that real time. So they were doing the basic programming part to start the program and even understand how the signal sequences work and how vehicle modes work. So that was phenomenal. I think that hands-on experience has kind of sparked a lot of interest. And as we developed from just giving that hands-on experience, we moved on to showing them real-world demonstrations. So we had them walk at a crosswalk, created a mock crosswalk, like an intersection, showed them how real traffic cameras can start detecting and counting people at an intersection, and how that information can be used to impact traffic signals. Like, can there be a traffic signal extension if a disadvantaged person was detected? So we started generating these questions, show them how connected vehicle technology can work, and that sparked great questions. They started asking, okay, how does this camera detect in different weather conditions? What intersections currently that we have in Cincinnati area, do they have this technology enabled? How long does it take? Are there any regulations? So all these questions are great questions to be answered, which I studied in my PhD. This is the research setup that I put together for the Cave in a Box, which is connected and automated vehicle education in a box. The previous one you saw is a light version, like desktop version of it. This is more of the real world components assembled together, which we took to the field and started doing some real world demonstrations of pedestrian detection, sending those messages to the vehicle, completely wireless in a secured format. And then start seeing the reaction of the driver, understanding how the safety can be impacted on using roadways in different conditions. So I think that's where my 2023 has been, was fantastic experience. And as I said, I really hope with all the, I'm sure together we probably are, reached to at least 500 students between Ryan's group and our group. And to see that spark translated into this quantified improvement that you see on this slide right here, where students previously do not consider or have not considered transportation as their career pathway, started thinking, okay, this seems interesting and we should consider this as a career pathway. So I think that's a great tool that we used to be able to spark that interest in students. Hopefully, as I said, we'll take STEM as their main career pathway in the future.
For sure. And I got to say, the energy at both of those camps was just through the roof. I was down there to see part of it, and you were both running the same week. I remember I was kind of splitting time between both events, and it was something, boy. That seeing all that this doesn't show the full auditorium, but you had a room full. And Si, you had students from really all over the country for your program. Is that right?
That's right. Yeah, I think this College of Engineering summer camp, I think recruited from at least 8 or 9 different states from the US. I think there were students from Japan as well who joined. So it was a very diverse group of students and very exciting group, I would say, because I think they're going into the high school, so they're excited to start trying out some coding and understanding how different mechanisms work. And I think that's where, interdisciplinary aspect of transportation comes into the picture. Somebody maybe just computer science related interest can be translated into, programming a vehicle, for example. So that kind of impacts transportation in a much bigger way than they previously expected. So that sort of learnings were really, really important at that age.
Absolutely. Well, I know Ryan alluded to this, and we'll talk with each of you about some of the resources that came out of that work you did that summer, because it was not just the summer program. That was really, the sort of the hands-on implementation of it. But this has all been published, and so let's talk a little bit about what resources are available to support K-12 educators who are in the audience watching this webinar with us here. So. I'll summarize by saying when you go to the DriveOhio Educator Toolkit, as Ryan mentioned, there's several pieces of content inside there through the different pieces of curriculum related to this connected and automated vehicle education that our friends from University of Cincinnati have developed. Si, we'll start with you. There's a couple different pieces that you published. If you could maybe just talk us through a little bit more of the detail of what's in there and what they might expect when you check out this curriculum.
Yeah, together with Dr. Arthur Helmicke, Dr. Victor Hunt, Dr. Whitney Gaskins, and the Gaskins Foundation, we came up with this traffic light simulation, which is almost like an early stage understanding of how traffic lights work and how intersections work. So consider this for grade bands, 3 to 5 and 6 to 8. Students don't really understand what real world equipment kind of looks like. So for them, it's just them acting as different components in an intersection. So that's what you see in the left, where these dots reflect students who are simulating how a traffic light works. So they're just trying to understand how vehicles queue up at an intersection, who gets the right of way first, and what happens when there are different signals that are conflicting with each other, right? So how does that signal phasing kind of works? And then as a second phase or second level to that traffic light simulation, they take a piece of paper that has the traffic light pretty much printed, and they use copper tape and a battery pretty much and 3 LEDs to kind of develop this basic electric circuit to show how red, yellow, green kind of lights work. So this is a good exercise. As I said, that interdisciplinary aspect of transportation is really important for them to understand. They'll start seeing that basic electric circuit using little things can actually translate into a traffic signal in future. So I think this is a very early stage understanding of how intersections work, how traffic lights work in real world.
That's great, and that curriculum includes, if I remember right, some of the parts and components they would need. So anybody could put this together. Is that right?
Absolutely, it's very easy to put together. Doesn't need a lot of preparation. I think the document that comes along with this curriculum pretty much highlights basic requirements that you need and how many students you may need to act as different components at an intersection. And the rest of the stuff is just you printing things out, and they'll start playing with it, and they'll come up with creative ways of assembling a traffic light circuit.
That's great. And then you've got the cave light, which you kind of gave some of the overview there, but this is a little behind the scenes and the how-to of how to build your own. Is that right?
Absolutely. And let's say a student has actually gone through the first 2 traffic light simulation aspect of it. This should be relatively simple because half of it is infrastructure kit, which is the traffic light signal, but it's running on a Raspberry Pi. So the code that's being run is actually simulating how a real world traffic signal kind of works. So we're just looping that thing through so that it goes from green yellow, and then red, and then keeps going like that. So those phases are, we are using a wireless router here to translate or to send this packet of information to the vehicle, which is also equipped with its own Raspberry Pi. It's receiving those messages, and suddenly you'll start seeing the vehicle rotating its wheels. When it's green, slowing down, the speed will reduce when it's yellow, and then it'll stop when it's red. So just being able to come up with that sort of setup will give them a great understanding of how connected systems work, how sensors work, and how autonomous vehicles are currently operating. So again, this is probably a little more high school level education. There is a little bit of coding involved, real world circuitry involved. Understanding Raspberry Pi can open a lot of channels for them, not just in coding aspect, but also, how to use hardware, how to hook sensors, read the inputs, and control some outputs. So I think this is a fantastic platform to understand what control systems mean, which is what they'll start learning in their undergraduate level.
That's right. And while it was clearly used in the summer program, there's no reason this couldn't go into a classroom setting as well, right?
Absolutely, absolutely. One of the undergraduate students that worked on this with us, John DeSouza, he got an internship at Honda last year. So you could see how some of this can translate into real world co-ops and really good companies.
That's great. And this was one of the awesome programs your team supported, the Girls in STEM Day at UC, which is just a hoot. I mean, every time I've been down there, it's just such high energy, and everybody's got their lab coats on, and it's just outstanding. So we appreciated you doing that. And you had a whole bunch of students that day, is that right?
Yep. A lot of fun. Girls in STEM is always exciting because you get to see these girls who are excited to start coding and start getting hands-on on these vehicles, which is really, really nice to see.
And shout out to the Greater Cincinnati STEM Collaborative for hosting that. A great annual program, one of many that they host. Thanks for that. And Ryan, a similar question. We got a couple pieces of curriculum that you've helped us publish as part of your work. You want to talk us through each of these a little bit?
Yeah, absolutely. One of the things that we wanted to do at the very beginning of this project was to get the input of educators from the start for a variety of reasons. Number one, we wanted to understand exactly what their needs were, but we also wanted to make sure that whatever we built could actually be aligned to Ohio learning standards, such that it could be part of that classroom experience, such that it could be taught but also testable, which we understand is an important piece of any curriculum or any lesson plan that's published. And so with our scaled, connected and autonomous vehicle system, there's so many jumping off points and so many opportunities for additional learning. So, in this system, what do we find? Batteries, conservation of energy, programming languages, inputs, outputs, systems, robotics, object detection, and the list goes on and on and on. We offer on the DriveOhio curriculum toolkit, the DriveOhio toolkit, a number of lesson plans. I'll comment here on the one that is referenced in this slide. In the world of civil engineering, we when it comes to pavement marking, so think of a roadway and think of the pavement markings associated with that roadway. For them to be of good quality, we refer to a parameter that's called the retroreflectivity of that pavement marking. In other words, how quickly light can be, sent and returned back to the source from any given object. And obviously, specifically when you're talking about nighttime driving conditions, the retroreflectivity of pavement markings, such that we can see them in the dark against the beams of our headlights, becomes rather important. Machine vision, in other words, camera sensors, are highly variable based upon lighting conditions. And so this is a project that sets up our students to be researchers. And so the title of it is Test Track Construction, where they'll actually build their own scaled version of a test track that this car can drive on autonomously. And even in doing that, you're learning specifically for maybe the middle school students, you're learning about measurements and systems of measurements, imperial versus English, and those types of things. And we kind of built that into the curriculum as well. But you could take it a step further and build that test track using different types of tapes, different types of pavement marking tapes. We would use a standard duct tape, but we'd also use kind of more of a matte finish gaffer's tape. So one being highly reflective, one being not so much. And we would, in this particular project, use our scaled and connected autonomous vehicle to test different lighting conditions and different pavement markings to optimize the design of the camera. And so it allowed us to kind of situate our students in the position of researchers. We didn't know exactly what the answers would be. We've tested this out. We've actually had the opportunity to execute this lesson a number of different times, most recently as part of the summer programming at Aiken High School, which is a Cincinnati public school right here down the street from Cincinnati. But it was a very, very cool experience in which we got to really understand what are the variable inputs that are affecting, that are influencing the design of my connected and autonomous vehicle. That was the interesting thing. And so in everything that we were trying to do, we wanted to evoke as many critical thinking skills as possible. And it was so fun to see the students get engaged and develop a matrix and determine what parameters that they would use and how they would test it and what criteria that they would use to determine what was good, better, best, and everything in between. So we've also done, since our camp in the summer of 2023, a lot of different classroom outreach using the content that's, again, available on that DriveOhio Toolkit site. Like size group, we were able to participate in the Girls in STEM camp. We've had a number of different visits to Reading middle school and high school, so frequent that we actually now have a Reading Eng2U engineering club that's exploring these technologies and these resources on a monthly basis. And so I forgot to mention earlier, but that camp, in addition to student participation, also offered breakout sessions and opportunities for educators themselves to get involved and to kind of go through a tutorial of the content that we were offering, which is, again, now available on that DriveOhio Toolkit site. So a lot of cool classroom outreach. I think in total, we probably partnered with maybe a dozen schools talking about smart infrastructure and smart mobility and a lot of cool stuff.
That's outstanding. Yeah, and I think one other piece that we've got featured in the toolkit is this smart infrastructure challenge, right? That's almost more of not quite a writing challenge, but it's got some different elements to it, right?
It is, and so we really wanted to, in this particular lesson, pique their curiosity of what was possible after this was built. And so what we offer most inexpensively is a connected autonomous vehicle that relies on a camera sensor. But in this particular project, we kind of open up their horizons a little bit, and we explore what's possible if we were to integrate another sensor, specifically LiDAR. And so it's an opportunity for our students to learn about LiDAR, LiDAR being light detection and ranging, which is a really cool sensor that's used predominantly in surveying technologies, but is becoming more and more popular in lots of different engineering disciplines. So it was an opportunity for us to teach on that, but also think about how the vehicles and the infrastructure are in fact connected. And so this project really hits on some of those key things and gets them thinking about the way in which they would design these future cities.
That's great. I love how this one in particular brings in some technical writing in there as well. So as you've mentioned,
yeah,
you can get different standards weaved in there. Sometimes it's measurement, sometimes it's English language arts. There's a lot of different ways you can merge technology into the classroom, right? Excellent. So as we start to wrap up our discussion today, I'll ask both of you to just share your thoughts. What advice would you offer to students who are thinking about careers in transportation? What would you want to share? And whoever would like to take it first.
Yeah, I can take it. I think, just with some 8 years old experience in manufacturing and automation, and working through this project at University of Cincinnati through my PhD, I think just that interdisciplinary aspect of transportation brings in everybody. Like if you have interest in something, I'm sure you'll find something in transportation that you could contribute towards. And it's so diverse that, computer science, electrical engineering, civil engineering, mechanical engineering, everybody can contribute to transportation. So irrespective of what specific interest somebody may have, I think they have a great career in transportation, hands down. I've seen that as a real example where I know that John, the undergrad that I kind of mentored through my PhD, his focus was on coding. That's what he wanted to work on. But through the process, he learned a lot of things. So now he's industrial engineering co-op, I think, at Honda. So controls integration as well. So it's really, how you learn some of these things through the components that are available through the educated toolkit can set your career up in a very solid way. So that's what I would say.
Sai, yeah, I mean, we didn't talk prior on this particular question, but I couldn't agree more. I think my response would be as succinct as be a lifelong learner. That's what I would offer to anybody who's thinking about the possibility of engineering, for two reasons. Engineering is changing so fast and so frequently that in order to keep up, you're always having to learn something new. Here we are, Sai, Rich, master's degrees, PhDs. I feel like I have so much left to learn, and I'm so excited to learn it. So I think being in that posture of a lifelong learner, and also engineering, the disciplines, the silos are falling very quickly. There was a time, even when I was in my undergrad, when civil engineers would do civil engineering things and electrical engineers would do their electrical engineering things. Now, not so much. Everybody's a programmer. Everybody has to have a sense, or at least maybe a kind of a practical knowledge of what the partners on any given design team are working on, if for no other reason to be able to have intelligible conversations with them. I certainly don't know everything there is to know about programming and automation, but man, I work with some really cool researchers who do. I'm also very aware of my own strengths and what I can bring to a team. And so that being the case, I think with that posture of being a lifelong learner, with the excitement and the possibilities of learning something new, that's a great place to be for a young person.
You're on mute, Rich.
Sorry about that. So thank you both for those perspectives. Lots of great points about the interdisciplinary nature of things, the ways that the different skills are needed, including art. Some of these illustrations I was shown in the background have a definite artistic flair to it. So I want to thank you both for joining us here today. Great conversation, great collaboration that continues. Check out the resources that they've described here and reach out to us anytime if you've got questions about the work that's been described. Any closing remarks you want to add that we've missed here today as we wrap up?
I would say if there's any educators who ever want to learn more or have questions, feel free to reach out to myself here at the University of Cincinnati. I'm sure, Rich, if you wanted to, in a follow-up note, or maybe, even in the chat of this call, offer my email address. And we're happy to provide tours of digital features, and lots of really cool learning opportunities. And sometimes that's as simple as, hey, allow us to come into your classroom, have your students meet an engineer, maybe some simple Q&A, and things like that. We love to do that. And anytime that we that we have the opportunity to do that, we want to say yes. So feel free to extend that invitation. We'd be grateful.
Yeah, likewise, any questions, happy to answer. That picture reminds me of my trip to Netherlands during my PhD. So I can't wait to have a lot of intersections that we have in Cincinnati area to start looking like that. I think, yeah, as I said, it could create real impact on the way we live by being in transportation or contributing to transportation. So yeah, looking forward to many more conversations that'll come out after this.
Outstanding. Yeah, the collaboration continues, and there's great things happening at the University of Cincinnati, and we'll have some more to share on that soon, so stay tuned. So as we wrap up today, how can you learn more about the DriveOhio Educator Toolkit? We've shared the QR code here. Feel free to check out the website. It's all free. Reach out to us with any questions anytime. You can book time with us to talk through this. If you're not sure how to get started, when in doubt, just shoot us an email or book a Teams call with us, and we're glad to talk you through ways to get started and with any of the resources we've been talking about. I mentioned earlier that other episodes of Toolkit Tuesday are available through our YouTube playlist. Just check us out find DriveOhio on YouTube, and you can scan through those and watch for more episodes soon to be announced. And we'll have about one a month through the end of the school year. So stay tuned for more details very soon on all of that. I don't see any other questions in the chat at this time, so I think we'll wrap up today's discussion, but we'll say thank you again for joining, and we will see you next time.